Welcome to RSET online lectures on the subject CS309 Graph Theory and Combinatorics for the semester 5, continuation of module 2 with part 5. In a directed graph, we can define the degree of vertices as follows. The number of edges incident out of the vertex V is called the out degree and it is written as D plus V. And the number of edges incident into V is called the in degree and it is denoted as V minus V. In the directed graph given in the example, consider the vertex V1. E3 is incident into V1. Therefore, D minus V1 is equal to 1. And the number of edges incident out of the vertex V are E4, E1 and E2. Therefore, D plus V1 is equal to 3. Similarly, we can find the in degree and out degree of all the vertices. And see the sum of in degree and sum of out degree. We can prove that sum of out degree equal to sum of in degree equal to 10. For every directed graph, sum of in degree equal to sum of out degree. An isolated vertex is a vertex in which the in degree and out degree are equal to 0. A vertex V in a digraph is called pendant if it is of degree 1. That is D plus D minus V equal to 1. Two directed edges are said to be parallel if they are mapped onto the same ordered pair of vertices. Next, isomorphic digraphs. Isomorphic graphs are defined such that they have identical behavior in terms of graph properties. For two digraphs to be isomorphic, not only must the corresponding undirected graphs be isomorphic, but the directions of the corresponding edges also agree. See the example. In the vertex, edges, etc., they are isomorphic, but see the edges E4 in two figures marked in red line, they are of opposite direction. Therefore, these are two non-isomorphic digraphs. Next, we can define types of digraph. Simple digraph. A digraph that has no loop or parallel edges is called a simple digraph. Asymmetric digraph. Digraph that have at most one directed edge between a pair of vertices but are allowed to have self-loop are called asymmetric or antisymmetric digraph. Next, define symmetric digraph. Digraph in which for every pair of vertices AB, there are edges from A to B and B to A. That means for every pair of vertices, there are two edges in. Next, complete digraph. A complete symmetric digraph is a simple digraph in which there is exactly one edge directed from every vertex to every other vertex. A complete symmetric digraph is a asymmetric digraph in which there is exactly one edge between every pair of vertices. A complete asymmetric digraph of n vertices contains n into n minus 1 divided by 2 edges. This is already we discussed in module 1. But a complete symmetric digraph of n vertices contains n into n minus 1 edges. The reason is for every pair of vertices there are edges in two directions. Therefore, number of edges will be n into n minus 1. A digraph is said to be balanced if for every vertex Vi, the in degree equals out degree. It is also referred to as pseudo-symmetric digraph or an isograph. A balanced digraph is said to be regular if every vertex has the same in degree and out degree as every other vertex. With this, we complete module 2. Thank you.